Section 10.1, the ellipse. An ellipse is the set of all points P in a plane, the sum of whose distances from two fixed points, F1 and F2, is constant. These two fixed points are called the foci, the plural of focus. To draw an ellipse, we would place two pins at the foci and tie a string to each of those pins, and then we would pull the string tight with a pencil, and the path that we trace out would be an ellipse. Notice that since the length of the string is a constant, then the sum of the line segment from the pin to the ellipse and then back to the other pin will always be the same. An ellipse can be elongated in any direction, horizontally or vertically. The vertices are the 2 points on the ellipse that are on the same line as the foci. The line segment that joins the vertices is the major axis, and the minor axis of the ellipse is the line that's perpendicular to that goes through the center. The midpoint of the major axis or the minor axis is the center of the ellipse. The standard form of the equation of an ellipse is shown. On the left, we have x squared over a squared plus y squared over b squared equals 1. Note that a squared is always a larger value than b squared. So when the larger value, a squared, is in the denominator of the x squared fraction, the ellipse will be elongated in the x direction. On the right, we have x squared over b squared plus y squared over a squared equals 1. So when the a squared, the larger value, is in the denominator of the y squared fraction, the ellipse will be elongated in the vertical, the y direction. The vertices are on the major axis, a units from the center, and the foci are also on the major axis, c units from the center. We can find the foci using the equation c squared equals a squared minus b squared. The other form of the equation solved for b squared is used when they tell us the vertices and the foci and we want to find the values on the minor axis. Example 1. Graph and locate the foci of 16x squared plus 9y squared equals 144. We want to put this equation in standard form. To do that, we need 1 on the right, and we can get that by dividing the right side by 144, giving us the 1. If we divide the right side by 144, we'll need to divide the left side by 144, and then we reduce those fractions. Now that our equation is in standard form, we can find the vertices. Because the denominator of y squared is greater than the denominator of x squared, the major axis is vertical. A squared equals 16. We take the square root of both sides, giving us a equals plus or minus 4. So the vertices will be 4 units up and 4 units down from the center 0, 0. Next, we'll find the endpoints of the minor axis. Because the denominator of y squared is greater than the denominator of x squared, our minor axis is horizontal. B squared equals 9, so b equals plus or minus 3. So the endpoints of the minor axis are 3 units to the left and 3 units to the right of the center 0, 0. To find the foci, we'll use the equation c squared equals a squared minus b squared, where a squared is 16 and b squared is 9. So c squared equals 7, and c equals plus or minus the square root of 7. Because this ellipse is elongated vertically, that radical 7 will be up and down from the center 0, 0. So now we can graph. Our vertices are up and down 4 units. The endpoints of the minor axis are to the left and to the right 3 units. So we draw our ellipse. Our foci are up and down radical 7, which is approximately 2.6, and that's our graph. Example 2. Find the standard form of the equation of an ellipse with foci at negative 2, 0 and 2, 0, and vertices at negative 3, 0 and 3, 0. Because the foci are located on the x-axis, the major axis is horizontal, and therefore the form of the equation will have the a squared underneath x squared. The distance from the center to either vertex is 3, so therefore a is 3 and a squared equals 9. The distance from the center to either focus is 2, and therefore c is 2 and c squared equals 4. So we can find b squared by using the formula c squared equals a squared minus b squared, or the version b squared equals a squared minus c squared. A squared is 9 and c squared is 4, so b squared equals 5. So we can put a squared and b squared into the formula. And our equation is x squared over 9 plus y squared over 5 equals 1. Example 3. A semi-elliptical archway over a one-way road has a height of 10 feet and a width of 40 feet. Will a truck that is 12 feet wide and has a height of 9 feet clear the opening of the archway? We can begin by constructing a coordinate system with the x-axis on the ground and the origin at the center of the archway. Using our equation for an ellipse, we can express the equation as x squared over 20 squared plus y squared over 10 squared equals 1. The 10 comes from the height of the minor axis y, and the 20 is because the total width was 40, so the distance from the center to either vertex is 20. That equation simplifies to x squared over 400 plus y squared over 100 equals 1. The edge of the 12-foot wide truck corresponds to x equals 6 because half the truck will be on one side and half the truck will be on the other side of the center. We find the height of the archway 6 feet from the center by substituting 6 for x and solving for y. So we take our equation for the ellipse and we substitute 6 in for x. Then to clear the fractions, we multiply both sides by the least common denominator of 400. When we multiply 400 times the first fraction, the 400s cancel and 6 squared simplifies to 36. When we multiply 400 times the second fraction, 400 over 100 is 4, so we get 4y squared. And on the right side, we get 400. Next, we subtract 36 from both sides, and then we divide both sides by 4, and we get y squared equals 91. We want y, so we take the square root of both sides. We get y equals square root of 91. We can ignore the negative possibility because this is a distance, and that works out to approximately 9.5. The height of the archway at the sides of the truck, 6 feet from the center, is approximately 9.5 feet, and therefore the 9-foot truck will clear the opening of the archway.